Good evening, everyone. Today's we are going to discuss about the clustering algorithm, that is K-means. So basically, when we talk about clustering, it is basically an unsupervised learning method, and in which we don't know the data, the correct options. So we need to identify the patterns in the data, and based on the patterns, we are going to cluster them, right? So our task is to divide the data points into number of groups, right, such that the data points in the same groups that have the similar patterns must be lying in the same group. Then the other part, like suppose I would be saying we have some circles, we have some triangles, we have some different shapes. So we are going to segregate the items, the data items, and put them in another clusters. So this is the method, this is the concept, this is the basics of clustering. So let us understand and let us apply how we use this clustering using a k-means clustering, right? So what is our aim? What is our goal? Our goal is to segregate the data points, and we need to make a cluster which is containing the data points of similar patterns, right? Like all of them must be having the same pattern. In this cluster, all the items will be having the same patterns. So yes, it is an unsupervised learning method. It requires data but no labels. We are not going to say that like we are training the model with the correct answers, right? No. Here we don't need the labels. We are going to identify the data based on the different patterns. Now, what are defect pattern first of all? Like suppose we have group emails, search results, customer shopping patterns, regions of images. Like if I am talking about this image, our goal, basically what is our aim, what is our motive? Break up the image into meaningful and perceptually similar regions. Like this would be different from the this side, right? So or this side would be different from this side, so we have to basically segregate both of them. So there would be a number of types of clustering, right? It is not like we are talking about only a single type of clustering. There might be there are different methods. So according to the application, we are going to apply the type of clustering. So the first type of clustering that we have is our partitioning methods. It is nothing, it is simply the division of set of data points into non-overlapping clusters such that image object isn't exactly one subset. Like it is not falling under different sets or different subsets. So that is called partitioning. Like in this case, it is partitioned, right? You are segregating. This is another thing, you have partition, then again there is some river, then again there are some grasses, or you may say some highlighted regions. Like it might be having some different color, or it might be having some different region. So we basically detect it, and it is you may be detecting through edge detection algorithms or clustering. So next clustering algorithms would be your hierarchical clustering. Now what is hierarchical clustering? Hierarchical clustering may like what we make is we apply the algorithm to make a hierarchy of clusters, right? We have hierarchy of clusters in that. So we might be using any of the technique like agglomerative, or we might be using divisive clustering in that. So we make dendrograms, right, for segregating the data points. And we through dendrograms we can easily find out like this point is falling under this cluster. So it is a type of, you may say, it is also called nesting clustering. Why? Because the dendrogram looks like when you fetch out that part, when you derive the dendrogram using any of the method, like even if you are using agglomerative clustering or you are using divisive clustering, so any of the method you may use it for making the hierarchy of clusters, right? Yeah, it is a form it is basically when you draw the whole dendrogram, it is like a tree-like structure, right? Then we have fuzzy clustering. It is used to reflect the fact that an object can simultaneously belong to more than one group. So it might be possible sometimes like the data point is falling under more than one group. Then we can apply the fuzzy clustering. Then we have is density based clustering, right? In density based clustering, we are basically finding out the density of the data points in the data space. So here we will be searching of like what are our neighboring points, and it is basically taking the three values. Minimum 3 points are required, and like I will be sharing more sessions on this, like how we can have the types of clustering and how we can make the dendrograms, or how we use this density based clustering, or we call it as DB scan clustering, right? Then we have model based clustering. Model based clustering is basically it provides only the framework for incorporating a knowledge about a domain. So it is like it is basically a framework, or you may say it is specific to a particular domain. It talks about like this, right? Next we have is partitioning based clustering that we have to start. And in this, like how to segregate the data points using partitions. So to minimize the intra cluster distance, like how to minimize that we can use the partition based clustering, right? So because we need to segregate the different data points, and we need to understand this thing, like this data point is falling under this group only. We cannot say that this is falling under this group, because the distance would be, then in that case would be more. So we know that if the yeah, sometimes it happens like you have a data point here, so it might be possible like you can calculate the distance from here to here, and which is the minimum, you fall that particular data point into that particular cluster, right? Now we are going to start with the k-means clustering. Very important type of clustering, and most widely used in different applications. Like it is most popular clustering algorithms, and yes, it is very simple and easy to use method, and most of the like applications are most of the applications are using k-means clustering. So yes, it is an iterative clustering algorithm. It is partition based clustering. Each cluster is associated with a centroid. So a k means we are putting the we are calculating, like we are initializing one of the data point as centroid, and then we calculate the distance from this particular centroid, and using like Euclidean distance method, right? So here we have each point is assigned to the cluster with the closest centroid. So how it works basically, like suppose we have a data points, we have different data points, right? So what is the value of k is basically the number of clusters, so that needs to be decided in before, like when you are making the clusters. So k is nothing, k is the hyperparameter here that is used as k, right? K means your number of clusters. So suppose I would be saying like my k value is 2, so my whole data set is segregated into two clusters. My whole data set is segregated into two clusters. So suppose here there are number of points that are lying within this cluster. So what I am going to do is every time I am going to take one centroid, and I am going to calculate the centroid value, and then we are going to put that particular data point into that particular cluster. So suppose this is my centroid and this is my centroid, and I am going to calculate the distance, the minimum distance, the point, the distance which is like if it is a minimum distance from this centroid from cluster 1, so it would be falling under this. If it is like the distance is minimum in this cluster, so this data point would be falling in this cluster. So this is how it is basically putting the different data types into different cluster, and each time the cluster value is incremented, right, updated basically. Now how it is updated, how it works actually, let us understand this part. select the k points. Now what is k? K is a hyperparameter, and you need to understand the number of clusters that we have, that we take it as initially centroid. So you need to identify any of the, you can take any points, any data points as the centroids. It is not mandatory like you are going to start from the first 2 points or end or the last 2 points or middle 2 points. No, you can take any of the point from that particular data set, right? Form k and repeat that thing, right? Form k clusters by assigning all points to the closest centroids. Then you are going to check out like this data point is suppose this is my centroid point and this is my other point. So and this would be my another centroid, and this is also a data point from the data set itself. It is not a different point, right? So what you are going to do is you are going to calculate the distance using Euclidean distance method from both the centroids. If the data point is like having the minimum distance using k2 using this centroid, then this data point will be falling in this cluster, and each time when you are putting any data point to any of the cluster, that means your centroid value will be updated, right? You need to recompute your centroid of each clusters. So I will be telling you like how it works. Right. So this is our flowchart. Like you start with the number of clusters. So here we have to define like at the start, like suppose I am saying k is equal to 2. That means our whole data set is divided into two clusters. Our data points will be falling either in this or in this cluster. So this means like k2 means you have two clusters, right? Then take any of the data point as centroid. Like suppose there are different points here and different points here. So you need to select any of the 2 points as centroid. Then calculate the distance of different data points from that particular centroid. And each time when your cluster is updated, your data point is updated or data point is calculated and your distance is calculated, each time when it is basically updated, you are going to update that cluster and update the centroid value too, right? Now let us understand with the help of different steps and the numerical. So you have initial centroids are oftenly chosen, because this is the drawback of this, like we don't know what is from where you are going to start, right? So yes, it is randomly chosen as a centroid. Clusters produced vary from one run to another. So it might be possible like suppose I am using a cluster points as first two data points and you are using something else. So yes, it would be a it matters, and it is going to, your output would be different in that case. The centroid is typically the mean of the points. Yes, we will be using Euclidean distance method for calculating the distance between, or it is very important method for checking out the closeness, or you may say the distance between two data points. K-means will converge for common similarity measures mentioned above. We have already seen like when we have the data points and we are checking it out, like they fall in some of the groups, either this or another group. Most of the conversion happens in the first few iterations. So you like whenever we apply this thing in the first few iterations only, you are going to find out like the particular data point is falling in cluster 1 or in falling in cluster 2. Often the stopping condition is changed to until relatively few points change cluster. So each time when you have your data point, like suppose this is my cluster 1 and this is my cluster 2. You might be having some data points like 1, 2, 3 and so on. So suppose I would be having one data point that is falling in cluster 1 and 2 that is falling in cluster 2 and 3 and so on. Right. So each time when your data point enters into a cluster, your centroid value will be updated, and the centroid value will be updated for that particular cluster only. It is not going to update the value for another cluster, right? So let us have an example. Here we have taken the hyperparameter, that is number of clusters, as 2. right? And these are our data points. This is our sample number and this is our data points in x and y terms. So here we can take our k value as 2. That means we need to select, our first step is to need to select two centroids, right? And so we will be taking the first, most of the time we take it as 2, but you can pick any of the data point. It is not mandatory to pick only the first two data points. No, it is not mandatory. You can pick any of them. Like there are 6 data points, any of them you can take it as a centroid and then start working on that and start using the k-means. So here what we have done, initially centroids are if the first value that we have taken centroid value as 185 and 72, and then k2 we have taken as 170 and 56. So these are our two centroids. Now what we are going to do is, let me explain you in a short method, like how to calculate the clusters, how to calculate the distance. What you are going to do is take this centroid x and y and then take out the difference between the other point, because like here, and if you are taking the 2 points as cluster 1 and cluster 2, here what is happening is, like if you are measuring for the point itself, obviously this would be nearer because there is no distance, that distance would be 0. And the same case, if you are measuring from cluster 2, this point, the distance would be 0. So this would be your minimum minimum distance. So this would be falling in the same cluster, right? Like your this point would be falling in k1 and this point would be falling in k2. So this is understood. So in case like it is not mandatory to have the evaluation on these 2 points, let us start with the third point, that is 168 and 60. So before applying this thing, first we need to understand the method, that is Euclidean distance method, and that is the formula for using this is, you have x and y, you have your x and y data points, and this would be your centroids. Like I suppose I am taking, this is my x point and this is would my centroid. For centroid 1, suppose I am talking for cluster 1. So and this would be my y point and this is my centroid y point. Then difference between both the points whole square plus this under root this thing, like x minus a, yeah. So this is, you are calculating one by one, like first you calculate this part, then you calculate this whole square of both of them, add them and then take out the square root. So what we are going to do is, like suppose this is my first point and this is my first cluster, like let us see how it works. This would be my cluster 1, this would be my cluster 2, so that we have already taken it as 185 and 170 or 150 56, right? So what we have done, so you are measuring from itself, so obviously it is like it is not mandatory to use these two steps. What we can do is like because their distance would be 0 if you are checking from both of them, like the distance between, if I am finding this point from both the clusters 1 and 2. So this is my same point. So yes, I will be following this point. This point will be falling in the cluster 1 and this point will be falling in the cluster 2. So no need to have this step. Let us move to the next one, that is 168 and 60, right? So now you are going to calculate this point with both the centroids, right? So how to calculate it? 185 minus 168, your this data point, and then 72 minus 60, right? This would be my second data point. So then perform the calculation and you will be getting 20.808. Same step for the centroid value 2, 168, that is your data point and this would be your centroid. So 170 minus 168 and 56 minus 60, right? So taking out the both the values, both the distances using Euclidean distance method. So yes, for the distance from K1 would be 20 point something. The distance from K2 would be 4.472. Yes, both the distance are calculated. Now you need to check out which distance is the minimum from the from that particular data point, from the centroid. So this would be my minimum distance from this for this particular data point. So my this point will be falling under which cluster, which has the minimum distance, that would be K2. So now my data point, this data point will be falling under K2. So note this thing also, whenever you calculate the distance between two data points, like this would be 0. So you are falling this data point 185.72 would be falling under K1, and same is for 176, 170 and 56. The data point is falling under K2, right? So the third point, that is 168 and 60, these are the two distances that we have calculated. The minimum distance that would we have calculated is 4.472. so this would be my cluster 2. So my this data point would be falling under cluster 2. Now whenever you update the any point into the cluster, when you basically this point is falling under cluster 2, that means your cluster centroid will be updated now. Now how? Because now in your cluster there are 2 points. Now here you have to update your cluster point. How to find out the centroid of this? The main point on which you are calculating is plus 168 plus your 170 divided by 2, 60 plus 56 divided by 2. In which cluster the basically you have added the data point, that cluster, that centroid value will be updated, right? So each time when you have to update, whenever a point is to be updated in any of the cluster, you need to update the centroid value as well, right? Now let us take another point, that is 179 and 68. Now our K2 value is not this one, 170 and 56. Now my centroid value becomes 169 and 58. So each time when a point is added to a cluster, remember this thing, you need to update the centroid value as well, right? So here now you are calculating the distance from K1 and K2. Now your centroid value would be 169 and 58 rather than 170 by 56, right? Now here you need not have to touch the cluster 1 because no updation has been formed, no point has been falling under this category, so no need to touch this cluster, right? Because there is no point that is added into this cluster. Now again the same procedure will be followed, like 185 minus 179 whole square plus 72 minus 68 whole square. Then take from the second centroid also, that is 179 minus 169 and then 68 minus 58, and then you calculate the distance between the distance of data point from for both the clusters, right? So here you will be getting 7.21 and the second cluster would be 14.14. So here which one is the minimum distance? That is 7.2. So here, like when we have 7.2, this would be my cluster 1. So now this time my cluster 1 will be updated. Now my this point will be allocated to cluster 1, and now my centroid value, I need not have to touch the cluster 2, I have to only touch the cluster 1. And what I am going to do, again the same procedure, 179 plus 185 divided by 2, 68 plus 72 divided by 2, right? And you update the centroid value. So this is how we calculate it. Let us take another point, that is 182 and 72. Again now my cluster, my K1 centroid would be not 85, 185 and 72. It would be like now it is updated to 182 and 70, right? So here we are going to take the next point, that is 182. Again checking the value, checking the data point from both the clusters, from both the centroids. So 182 minus 182 would be 0 plus 72 minus 70 whole square, right? And then for second also 182 minus 169 and whole square plus 58 minus 72 whole square. So you will be getting both the distance. In both the distance, from both the distance we can find out, like this would be my minimum. So again my data point will be falling under cluster 1. Again I need to update the value of centroid of cluster 1 itself. So what we are going to do, 182 plus 182 divided by 2, 72 plus 70 divided by 2. So now my centroid value will be 182 comma 71. No need to touch on cluster 2 because no value is updated, no data point is updated into this cluster, right? Now let us take the last point, that is 188. Now calculate the distance from both the points, that is 182 minus 188 whole square plus 71 minus 77 whole square. Now you will be getting again for second cluster, second centroid also, that is 188 minus 169 whole square, 77 minus 58 whole square. So you will be getting two distances, 8.4 and 26.87, right? Which one is the minimum? Obviously 8.4. So this point is again allocated to cluster 1. Again, once you have updated that point, you need to update the centroid point as well. So here you have updated it with 182 plus 188 divided by 2, 77 plus 71 divided by 2. Right, now your centroid, updated centroid positions are this one, right? Now now this is your last step, and this would be your, like, why you are applying k-means. So you have the data points, you need to understand, like, our clusters would be, our k value is 2. That means our whole data points are segregated into two clusters. Like this point is falling under cluster 1. So it looks like this, like your cluster 1. How we write it? So cluster 1 would be having your sample number 1, 4, 5, 6, 4, 5 and 6, right? So and your k cluster number 2 would be your 2 and 3. So your samples, your data points or sample number with 2 and 3 would be falling in cluster 2. So this is how we have segregated the data points using Euclidean distance method, and our hyperparameter would be 2 in this case. Why? Because we have segregated the data points under two clusters. Now let us understand what are the advantages and disadvantages of k-means. Yes, it is a fast, simple, easy to use and easy to understand algorithm, right? Relatively efficient. Why? Because sometimes it happens, like you need to decide. The first point is like you need to decide it, yeah, like the k value. So here where the k is your objects, k is cluster and d is the dimensions, yes. And that would be because it would be very efficient in terms of, like, when you calculate, if you know the values of you know how many data points are there and you know the number of clusters, and based on that you calculate it. Yes, it segregates and it gives you the best result, right? What are the disadvantages? The learning algorithm requires a priori specification of the number of clusters. If you don't know the number of clusters, how you are going to segregate the data points, right? The use of exclusive assignment, like if there are two highly overlapping data, then k-means will not be able to resolve them if your distance is too much, like very nearer. The learning algorithm is not invariant to non-linear transformation. With different representation of data, we get different results. So yes, this would be our disadvantage in that case. Euclidean distance measure can unequally weight underlying factors, right? So yes, it would be taken as one of the disadvantage. The learning algorithm provides the local optima of the squared error function, because in Euclidean distance we use this method only. Randomly choosing the cluster center. Yes, I told you it might be possible like if the result vary by choosing the centroid value. Applicable only when mean is defined. Fails for categorical data. Unable to handle noisy data and outliers. Yes. Algorithm fails for non-linear data sets. So might be possible like there are different advantages, but for every method we can say that for every method we can have different like the number of advantages, but we have disadvantages too for the same part. Right, hope you have understood like how to use the k-means algorithm and how to calculate, how to segregate the data points between clusters, right? So hope you like the session. Thank you.